Is there any questions? Is there a question? Oh, here it is. I couldn't find the share button. It moved. Okay. This is the outline you'll find up on As You Learn. So the exam is this week. It's broken into two parts. There's no new material this week, which I just mentioned, and you want to study your My Math Lab homework as well as group assignments. There's a take-home part. It will be up, hopefully, if I get it made. It will be up tomorrow, and it's due Sunday night. It will be over this part. It's over scatter plots R squared and the trend line, and it's over the equations and solving by graphing. Those two, because those two are the only two that use technology, and you either use Excel or Desmos. The second one, I don't know if you can use Excel. I've never tried to do that on Excel, but you definitely can use Desmos for both of them. So on your in-class tests, you will not need to use any technology other than a handheld basic calculator. So you just need a calculator for the in-class part. That's why I chose those two. Then these next two, we hadn't covered a lot about it. Like I mentioned it as we were doing a problem, but we didn't actually officially write it out. So I'm going to go over those today, but they are on the take-home part. Because on the take-home part, you can have your notes out. You can, I don't necessarily want you to work with somebody, but once you have your answers, if you want to check your answers with people and then figure out why you have a different answer, that's fine with me, because then you're learning this material. This bottom, well, all of this actually, we'll use a lot more later. So having it as a take-home isn't too big of a deal. I want to make sure you're understanding it and learning it, so then when we use it later, you'll still be tested on it. But yeah, domain and writing the equation in line when it's parallel and perpendicular. I touched on it, but we didn't do a lot of problems, so that's why it's take home. And then the story problem, because I wanted one more, so I put one on the take home, one on in class. And then difference quotient, sometimes some students they move really slow on it sometimes. And so I made that a take home, because we'll use it a lot later. Any questions so far? Now the proctored part, you'll get on just like you did today. So on Thursday, you're going to get on, and then I will give you, I think I can put a password for the test. You'll open up the test, and it's up to you if you want to print it. You don't have to, though. You can just have paper, start with number 1 and show all your work, and then number 2 and show all your work. So you don't have to have the test printed out. Another thing, sometimes some of the formulas, or if I put a picture of a graph on there, depending on what word you have, it may not come out exactly. Sometimes it's even a blank square. So I will also put pictures up there. So if it looks like the Word document's not showing anything or not showing everything, then you open up the pictures of the pages and you'll be able to see everything just fine. So I will have pictures as well as the Word document. You must show all your work for credit. That goes for both things. You can use a calculator. And since it's hard for me to tell if you have like little sticky notes all over your screen with the formulas, so you could have a formula sheet. That way, if everyone has a formula sheet, then it's not, I don't have to worry about it. But you do have to have your camera on. So I have to be able to see you. If your computer doesn't have a camera, then dial on your phone or your iPad because I know they have cameras. I have to be able to see you. To
So will we just log on like this regularly and then just start taking the test?
Yep, exactly. So you'll log on just like you did today, and then I'll be able to have you up on a big screen so then I can see everybody. Since we won't have to leave the main screen, I will probably put the lockdown browser on. I haven't used it yet on As You Learn, so I'm kind of hesitant. Maybe, I don't know, maybe if I won't use it, and then if I feel I need it, we'll have a short little quiz to test it out before we do it on another exam. Because I don't know. I'm hesitant with it. I've never used it on As You Learn. So you can use a formula sheet. The link is the same one you're using right now. Unless you're taking it early. There's one or two people taking it early because they have somewhere to go. So if you cannot be here on Thursday, let me know and we'll figure out a time. I have 3 classes on Friday, and I have someone taking it on Wednesday. Okay, any questions so far? When you're loading, and this goes for the take-home part and the in-class part, when you're putting it up, you can take a picture of it. I'm fine with that. There's also an app, it's called Scannable, and it works real nice. It scans it to a PDF file, and then you upload the PDF file. But if you just want to take pictures, that's fine also. Or if you want to type all your work out, you can do that also. Any questions so far? Okay. The best problems to try or to practice are these. Now, section 1.1 and 1.2, that was just solving equations and plugging values in, which that's all done in here. So I don't really need a test on those ones because you do it all in here. The only problems that for some reason are not in here are the domain of a function and parallel and perpendicular lines. So we will do one of each. I don't know if numbers got moved around and so it didn't put it in. I don't know what happened. Because I used the same one as last semester. So these are the problems if you want to take a picture of that, or, well, you can always go back because I'm recording it. Or you can write them.
Are these the problems that we did on class or do they relate to math lab?
These relate to my math lab. Sorry, I should have said that. Thank you. Yeah, these are from my math lab, and these are the ones we're going to use to practice. Now, if we don't get through them all, you could still do them, send me a picture and say, am I doing this right? Or, well, my labs will tell you if it's right. But if you're not getting it right, just send me a text and we'll see where you're missing it. But these are the best problems to study for the test. I thought I had a formula sheet. Must have threw it away. Formulas that you would need to know would be profit is revenue minus cost. Slope y2 minus y1 over x2 minus x1. The two equations of the line, y equals mx plus b, which is slope-intercept. Anytime you need to find an equation of the line, I always have it written in this form. You need this one to write the equation of the line. And then standard form, you don't need that one. Let's see what else is here. Slope. I think that's it for formulas. Oh. For equilibrium, you set supply equal to demand. And for the break-even quantity, you set, if you have profit, you set it equal to 0. If you don't, then you would have revenue and cost, and you just set them equal to each other. So I think that's it. Slope is also called rate of change. Marginal profit, marginal cost, marginal revenue. Difference quotient is f of x plus h minus f of x all over h. I think those are all the formulas. But as you're doing them, if there's something else you want to write, that's fine. Any questions so far? Yes, these are on the test. Well, problems similar to these. Any questions so far? Okay. I definitely want to go over, oh, you know what, other one? If you want to write it on there, you could. $40. Horizontal line, slope is 0. The equation is y equals a number. Vertical line, undefined slope. The equation is x equals a number. Any questions? Okay, I want to go over domain first and domain and parallel perpendicular lines, because we haven't done that officially, like written the problems down. So I wrote a few, because for domain, right now there's 4 cases. When we get into logs, there'll be another case because you can't take the log of negative number or 0. But for right now, these are our 3 cases. So I'm going to do these first. But is there any questions before I start? So for the domain, one case is when you have a polynomial. There's no fractions, there's no square roots. X is a member of all real numbers. Now, since we haven't done it a lot, I don't care how it's written. You could put X a member of all real numbers. You could put X is all real numbers. You could just put all real numbers. The other way is negative infinity to infinity. It's just all the numbers. So any one of the 3. Now when we have a fraction, we have to be careful because we can't have 0 in the denominator. So we take 2x minus 6, set it equal to 0, and solve. Once we get our answer, we omit that value. Add the 6 and divide by 2. So x can be any value except 3. So your domain is x cannot equal 3. Any questions on that part? When you have a fraction, set it equal just the denominator. Now a radical, think about when you take the square root. You can't take the square root of a negative number. So if you tried plugging in -4, take the square root of -4 in your calculator, it's going to be an error. Unless your calculator has imaginary numbers. So what you do is you take what's under the radical and make it greater than or equal to 0. I'm going to move this one for right now. Because we want to make sure it's 0 or positive. It can't be negative. And then you just solve. Add the 2 over. So x has to be greater than or equal to 2/3. Any questions on that? What happens with the 4th one, we put it into the denominator. Well, we still can't have a negative value, but now we can't have 0 either because it's in the denominator, and x can't equal 0 in the denominator. So instead of greater than or equal to, you just get rid of the equal to part and make it greater than 0. That way it's a positive number, not 0. Add the 2 and divide by 3. So when it's in the denominator, notice the only thing different is it doesn't have the equal to, because that would give you 0. Any questions on that? Okay. Now we can go back to 13.1, but any questions on domain? Why can't there be 0? On this one, there can't be a 0 because you're not allowed to divide by 0. And since it's in the denominator, this can't equal 0. So here it was okay because it wasn't in the denominator, but as soon as you move it to the denominator, you can't divide by 0. Usually on an exam, I'll have A, B, C, it's A, B, C, D. So it would break it into 4 parts, find the domain for each of them. And this will be on the take-home part since we didn't officially write it out. The other one that's definitely on the take-home part is this one, parallel and perpendicular lines. So we'll do the parallel one first. We have a given line, y equals 2x plus 5. We want to find the equation of the line that goes through this point and is parallel to this line. Now, if you remember on Desmos when we did 2 lines and they were parallel, their slopes were the same. So if you have two lines that are parallel, the slopes are equal. If we look at this line, 2x plus 5, what is the slope? Anyone? In y equals 2x plus 5.
2.
Yep. Because we're using y equals mx plus b, the slope is m, which is 2. And I use this for parallel, so then when I look back at my notes, I know this was the original one, this is the parallel one, and then I'll do something similar for perpendicular. But this is parallel. If the slope is equal, the lines are parallel. So it has to have the same slope. And then you use the point that's given and write an equation of the line. You can use y minus y1 equals m times x minus x1 to find the equation of the line. So we have y minus 6 equals 2 times x minus a negative 4 would be plus 4. It would ask you to put it in slope-intercept form. So we would distribute our 2 to x plus 8 and add the 6. So this line and the original line would be parallel. Any questions on that? Perpendicular lines, that's when 2 lines where they intersect, it makes right angles. So to be perpendicular, slopes are opposite reciprocals. What that means is you take the opposite sign and you flip it. So the slope of the line perpendicular to our original, which was 2. First, we change the sign. Since this one's positive, this one has to be negative. And then we need to flip it. When it's not a fraction, you can place it over 1 to make it a fraction. And you just flip it, so it's 1/2. So the slope perpendicular would be a negative 1/2. Any questions on that part? Then you do the same thing we did above, use the same point. y minus y1 equals m times x minus x1. Minus a negative 4 would be a plus 4. So we have negative 1 half x and negative 2. Add the 6. Any questions on that one? Okay. If you looked through and there's something you want to see, was there a specific one anyone needed to see? Or should I just start from 1.3 and go through? Okay, then we'll just start at the beginning. 1.3, I didn't have it printed, so I just wrote these two. Number 7 in section 1.3 on my math lab. Now yours might have different numbers because it generates maybe 4 or 5 different problems. A company charting its profit notices that the relationship between the number of units sold X and profit P. So X is our number of units, P is our profit. Is a linear equation. If 300 units gives us, or 300 units sold results in 38.54, and 375 units gives us a profit of 74.54. Find the marginal profit. Marginal profit is slope. It can also be called the profit from each additional unit. So any one of those three things mean to take the slope. Profit from each additional unit, marginal profit, slope. Your slope formula, y2 minus y1 over x2 minus x1. I think it's 48. Is everyone getting 48 for the slope? When each additional unit is sold, the y value, which is profit, the profit increases because it's positive by $48. You need to be able to explain what it means. Any questions on it? Part B, find the profit function. To find it, just like we found the equations in the last problem, we need a slope, which is 48, and then either one of the 2 points. I chose this one because 300 is a lot of zeros, but you could have used any one. So y minus 3854 equals 48, the slope, times x minus 300. Distribute the 48. Get negative 14,400 and add the 3854. Any questions on that part? Now, if you want, you can change your y to a p because it's a profit function, p of x. If I had you explain the y-intercept, this is the y-intercept, and it's a negative 10,000. So that means when x is 0, if no units are sold, we're in the hole $10,546, or we owe $10,546. We're in the negative $10,546. Any questions on the y-intercept? So it's because it's a negative, that means you're at a loss of 10,546, or you still owe it. I'll break even. I think it's in another problem, but this is a good one to do it for. When you have profit and you want to find the break-even quantity, you set it equal to 0. Because when your profit is 0, you no longer owe money. You no longer owe this 10,546. You've actually paid it off. Now you can start making money. So break-even quantity is the value where you no longer owe and you will start making money. Add the 10,000 to the other side and divide by 48. Now, usually your quantity needs to be an integer. Since they didn't give us what units this was in, maybe it doesn't have to. But no matter what this is, if you're rounding to a whole number, you'd have to round it up, even if it was 0.07, because that little bit you're not going to break even. So this would be 220. After we sell 220 units, we will start making money. Or we will no longer owe. Any questions on that? So it's important to know what these mean. Any questions? The other one from this section was horizontal. It's number 11. It says horizontal line, slope is, and then vertical line. Given either one, you need to be able to explain what they mean. And when you see, whether you see a drawing of a horizontal line or a vertical line, or they give it this way, you want to think of Hoy Vux. I'm putting the Hoy here because of the H. And this one goes with vertical because it's a vertical line. So we look at this one first. H is for horizontal line. O is the slope. So the slope is 0. And y is the equation. That means the equation only has a y in it. It's y equals some number. Vertical line, that goes with this one. U means the slope is undefined. And the x means the equation has x equals a number. So by memorizing Hoy Vux, then you can remember the special case. So that was number 11 from 1.3 on MyLabs. Any questions on it? One 1.4. So on section 1.4, you want to look at 4, 9, 10, and 12. That start is just where I stopped in another class. So number 4. An electric board determines its monthly bills for residential customers by charging a base price of $13 plus an energy charge of $10.31 for each kilowatt hour. I didn't realize this was in cents. So this is in dollars and this is in cents, so you want to be careful of that. But also notice this is a rate of change. It's cents for each kilowatt hour. Type an expression using X. Okay. So they must want it in dollars, although you don't have to put the dollar signs. So this one's already in dollars. This is our base price. Base price is fixed cost, starting amount, all of those are the y-intercept. No matter how much kilowatts you use, you are still going to have to pay, in this case, the $13. So that's the fixed cost. This is a rate. A rate of change is your slope. So it's 1031. Now this is in cents. So that would be, move the decimal over 2. If we moved it to dollars. So this would be 0.1031 X. So we had to change the units because this was in dollars and this was in cents. And that would be your equation. Any questions on that? So each kilowatt used, the cost goes up by 10 cents. If no kilowatt hours are used, you still have to pay $13. Is there any questions on explaining slopes and y-intercepts? Number 9. One thing that's nice with the homework, you can print it and like I did and just write on it. And it'll print more than one problem for you. Number 9. Notice this is one of our special cases. It says write the equation of a line whose graph is given. Horizontal. That's a horizontal line. So you want to think of hoi x. Since it's horizontal, we're using this. If we needed the slope, it would be 0, but we didn't need that. We just want the equation of the line. The equation only has a y value. So it's y equals, then see where it crosses the y-axis. 1, 2. So it crosses at -2. Equation y equals -2. Any questions on that? Number 10, the average rate of change. Average rate of change is slope. But you could also use this formula. F of b minus f of a over b minus a. Because remember, f of x is just y. So this is just y1 minus y2. Now, b and a, it goes from a to b. So in this problem, our a is the -6 and b is the -2. This is the equation. So for f of b, b is -2. That's going to be -2 squared minus f of a means to plug a in, -6 squared all over b minus a. You want to be careful. Exponents are first, so -2 times -2 is a +4. Here, we have to square this first and then multiply by that negative. -6 times -6 is 36, +36, but this makes it a -36. Same thing here, these two negatives make a positive. So we have -2 plus 6, which is 4. So as we go from a to b, the function drops a -8. Any questions on that one? Okay, this one again is on the take-home part. This is the difference quotient. So if we have this, now when I have a polynomial and I have to find it, I break it into parts. I first find f of x plus h. Then I subtract the original problem, and then I divide by h. I don't do it all at once. If you want to do it all at once, that's up to you. When you're doing it, what you're doing is taking x plus h and plugging it in for x. So we would have 4 times x plus h squared plus 7. Wait a minute. Oh, okay. I'm sorry, I missed someone's question. On the last one, the reason it was squared is because it said in the problem squared. If it would have said 2x plus 5, then you would have plugged it into 2x plus 5. But for number 9, it said it was x squared. So whatever the function is, that's what you plug these two values into. If they would have said 3x minus 4, then we would have plugged both of those into this. If they said y equals e to the x, then we would have plugged it in here. We didn't get into these yet, but we will. Yeah, so you only squared it because that said so. Thank you for answering that, Daphne. For number 10, well, this is the difference quotient. When you first plug in the x plus h, you want to be careful. The first thing students like to do is x squared plus h squared. But you can't because of that plus sign. It actually needs FOILed x plus h times x plus h. When you FOIL this, don't forget, don't lose your middle terms. If you can FOIL them all at once or combine them, for instance, I multiply my outside, I get xh. Multiply inside, I get xh, so that means there's 2 of them. So if you can skip that step, that's good. If not, that's fine also. Then distribute the 4. Any questions on that part? Now notice there's nothing else we can combine. So once you cannot combine anything, you subtract f of x. This part here. F of x is just your original equation. Now, a couple things work out nice here. That quantity, the f of x we're subtracting here, those should all cancel. The reason they're not canceling right now is because we didn't distribute the negative. So you want to make this a plus, and it will change the signs after it. So whatever sign they were, it'll be the opposite. Then notice the 4x squareds cancel and the 7's cancel. Everything in here should cancel or you made a mistake. That's how the difference quotient works. So this one drops out and the 7 drops out. Notice the terms, there's 2 of them, and they both have an h in them. We have 8xh plus 4h squared. Once you've canceled these, then you can divide by h. Any questions so far? On the top, we can pull an h out so that it will cancel in the denominator's h. You are not done with this problem until that original h cancels. Now there's another way of reducing it if you want, but what I did was I factored out the h and they cancel. The other way to do it is look at how many terms there are. There's 1, 2, 3, and I can take an h out of each of them. So if I take 1h here, I'm left with 8x. If I take one of the h's here, then I'm left with 4h, and I'm getting rid of the h in the bottom. So you can cancel one from each term, or factor out and then cancel. Any questions on that one? Okay, 4, 9, 10. That's everything from 1.3. Two point one is number 3 and number 6. Number 3. For the function f of x equals 6x minus 56, find the following. Find the 0 of the function. How do we find the 0 of the function? The 0 of a function, you set the function equal to 0. So 6x minus 150 equals 0. Just set it equal to 0 and solve. Add the 150. Divide by 6. 25. So the 0 of the function is 25. Any questions on that? The x-intercept. Well, when we're finding the x-intercept, we're letting y equal 0. So we're setting the function equal to 0. So the 0 of the function is the exact same thing as the y-intercept. And the last one, notice the solution of the equation 6x minus, oh, I wrote the problem wrong. Sorry. This should have been a 6. I'm not going to change it. It's almost number 3. I can do it again. I don't want you to have to change it. But the 0 of the function, you set it equal to 0. The y-intercept, you set it equal to 0. So then they're doing the same thing here. They're saying the solution of the equation when you set the function equal to 0. So 0, the y-intercept, or the x value when 6x in this case minus 150 equals 0. We'll do the other one. It looks like a 0 on the top on my screen, but then down here I could read it better. Oops, right there. Okay, so if we try the other one, 6x minus 156. Again, we're finding all three of these are the exact same answer. This problem is just to make sure you know the wording, so whichever I ask you, you're able to find. Add the 156, divide by 6, x equals 51. So for this one, the 0 or y-intercept would be 51. And I wrote the wrong. A was 0, B was x-intercept. Sorry about that. I wrote it wrong. This should be x. X-intercept. So I wouldn't ask this one, but I would ask one of these or both on maybe two different problems. But so you need to be able to find they're the exact same thing. Any questions on them? You just set your function equal to 0 and solve. Number 6. I added a part because it's just good practice, because you'll definitely see break-even quantity. The profit from the production and sale of specialty golf hats is given by X is the number of hats produced and sold. Oh, and right here it says P of X is profit. A, producing and selling how many hats will give a profit of $7,000? Well, if we think about it, if we're producing and selling, we want profit of 7,000. That goes in for profit. So see what you're given. Since we're given profit, we're plugging it in for P of X, which is 7,000. If they gave us the number of hats, then we would plug that in for X. Add the 7,000 to the other side. And divide by 20. So if we sell 700 hats, we will have a profit of $7,000. Any questions on part A? Part B, how many hats must be produced and sold to avoid a loss? To avoid a loss means you need to break even. To break even, just like before, we set the profit equal to 0. So you want to set your profit, P of X, equal to 0. Add the 7,000 to the other side. And divide by 20. So we need to sell 350 hats in order to break even, or 350 hats must be produced and sold to avoid a loss. So if you sell 350 hats, you won't owe any money. You're not going to make anything, but you're not going to owe. Any questions on that? So to avoid a loss, that's your break even when you're talking about profit, revenue, cost. Any questions on that one? Two point two works with the scatter plots. Whoops. I missed that there was questions. Why that's so small. Six divided by 6 is 2. Did I calculate one wrong? There were many typos made. On this one, I did. This should have been 26. I'm sorry. I was trying to get through all the problems and I shouldn't have rushed. This should be a 26. I was thinking this was 50 and added 1 because of the 6. So this one we did with 150. And then I did it again because the actual problem said 156. So the answer to 3 should be 26. Would be the 0. Sorry about that. It's just one of those days. So on your tests, show all your work. So if you do make these kinds of careless mistakes, you're only going to miss a half a point rather than the whole problem. So if I can follow it and it's just a careless mistake, I'm not going to take off a lot of points. Is there any questions on number 6? Okay. 1.5. On this one, it says determine whether the scatter plot on the right might be modeled by a linear function. Can the scatter plot be reliably modeled by a linear function? Well, notice it looks like it's exactly a straight line. Down 2 over 1, down 2 over 1, down 2. Yeah, this is exactly a straight line. So yes, it's modeled by a linear function. This is exactly modeled by a linear function because the slope of each one is exactly the same. down 2 over 1, down 2 over 1. So it can be modeled in a straight line. Any questions on that? When your r squared equals 1, that means all your data lands on the line, and it can be an exact linear function. So if r squared is 1, all the points land on the line. It doesn't have to be positive. It can be going down like this one is. But if they all land on the line, r squared is 1, and there's an exact linear relationship. Number 5, now on this one will be on a take home, but on number 5, because I got a lot of questions on the ones with the years. When you're adding these, or not adding them, but entering them into either Desmos or Excel, I think Desmos is easier, but either one. You want to read, notice it says X is equal to the number of years after 1990. This is what we're looking for. So X isn't the year, it's the number of years after 1990. So to find X, you need to subtract 1990. So 1995 minus 90 is 5. 2000 minus 1990 is 10. 2005 minus 1990 is 15. So you need to subtract this from each one to find your X value. You don't want to use the years. If you use the years, you'll still get the slope right, because when you subtract them, you're subtracting that beginning part for your Y's. Like if I take 1995, 2000 minus 1995, I get 5. 10 minus 5 is 5. You're going to get the same answer when you subtract the Y values. But it won't work otherwise for the rest of the equation. So if X is the number of years after a certain year, you got to subtract that and find the X's. Any questions on that part? Okay. I think we have time to graph it. To graph it, I'm going to use Desmos because I think it's the least amount of work. So I'll click on here. And we want to go to desmos.com. And then you click graphing. And it brings this up. Now, for graphing a straight line, you plug it in here, right on this line. But we're going to put the table in. So we want to go here. And you want to go down to statistics and then linear. So you just go down until you see this one right here, statistics linear regression. Notice it's showing the dots. Open the graph. And then you just want to, let's see, type in your X values. 5, 10, so it just goes by fives. 5, 10, 15, 20, 25, and 30. And then go to the Y values. 10, 12, 1356, 1981, And last one, 4425. Now notice it's not showing the graph at all. Well, that's because see where these numbers are? Look how large these are, and we're only going up to 12. So you go over here to this little minus and it'll zoom out until you find it. Like way, there we go. Looks like they're almost all on the line. No? I think I typed one wrong. Ten, 12. 13, 56, 19, 81, 29, 46. Okay. There we go. Now you can zoom in and out. That was a little too much. Let's go a little. Okay. It looks like they're almost all on the line. Notice this one's a little off. And so what that did was it changed the R squared a little bit. It's not a 1 because at least this one, if not, yeah, it looks like the rest are on the line. But to find your R squared, it's right here. To find your equation, y equals 135x plus 127, or 126.6. But you can find the equation right here. So any questions on that? Okay. Oh dear. So it gave us our equation, which of course I didn't write. Find the linear function that models it. You would write the equation here. So y equals 135.137x plus 126.6. And r squared, you'd need both for the test. Point. Any questions on that part? What does the model predict the expenditure will be in 2019? So for 2019, we need to subtract the 1990. That would be 29. We would plug 29 in for x. And it's in billions of dollars. Around 3 decimal places. And then this one you would set it the equation equal to this. But is there any questions on it? Then you just solve for x, which I know you know how to do that. How do you find x squared? Okay. Any questions on this? For x squared, on the TI-84, it has a squared right here. And so if we were putting in -6, notice that if you don't put it in parentheses, it's only squaring the 6, and you're going to get a -36. So when you want to square a -6, it has to be in parentheses, and then you can hit the squared button. Another way, if we had an exponent larger than 2, because they're not here, you use the caret. So you could use -6 and then this caret button and the 2. So for squared, you can just use this, but any other exponents, you would use the caret button and then put whatever value you need. Any questions on that? Where does this 6 come from? Okay. So x squared was a function. Forget which one it was on. This one. 4, 6. Here it is. Let me check. It was given. For the function y equals x squared, compute the average rate of change from -6 to -2. So those values were given. If we had y equals x cubed, find the rate of change from x equals a -2 to x equals 2. Finding the rate of change from two values, that's f of b minus f of a over b minus a. And it goes from a to b. So it didn't matter that it was an x squared. That was what was given. So whatever is given, and a and b will be given. So in this one, we would want to go from f of 2 to f of a -2, 2 minus -2. Because those are the values that were given. So that's why we used -2 and -6, and that's why we used x squared. That's what was given in this problem. If we were given 3x minus 4, then we would have used 3x minus 4. In my example, I grabbed x cubed. So we plug 2 into the equation and get 2 cubed minus -2 cubed over 2. A negative and a negative is a +2. Two cubed would be 2 times 2 times 2, which is 8, minus a -2 cubed is -2 times -2 times -2, which is a -8. So this becomes a positive all over 4. 8 plus 8, 16 over 4 equals 4. Did that help? So this function will be given, and that's what you plug into, and then you'll be given the two values from this one to this one. Any questions? Okay. In the book, what section is this? In 1.4, so 1.4, yeah. They should have more of these problems. And so if you want to try some, and then if you have any questions, let me know. Or if you want me to send you a picture of them from the book, let me know and I could take a picture. Text me, that way I could just take a picture with my phone and send it. So for the r squared, yeah. What is r squared? R squared tells you how close your points are. So if we had a scatter plot, I know it's past time, so if you have a class to go to, that's fine. It's recorded, so you can watch it later. These are kind of spread out more, but they're still kind of close. Like you can see it's going upward. This r squared is probably 0.7 because the data is further away from the line. Now the one we had just done, it was almost on a straight line. R squared was 0.97, I think. The closer this is to 1, the closer the dots will be on the line. The further out they are, the closer to 0 this will be. And so if the data was spread way out like this, r squared would be 0. So what r squared does is it tells you how strong a relationship the items have. If we were using the height and the arm span, there's a very strong relationship. So r squared is going to be close to 1. I had a student do the length of a tattoo and the price. That relationship wasn't too strong. I think it was like 0.45 because, well, it's not just the length, it's also the width. It's also how much ink, different colors, the amount of the ink, the detail in it. So it's more than just size in cost and size of a tattoo. So that had a weaker relationship and the dots were further apart. So knowing your r squared, you can tell how strong a relationship it will have. Closer to 0 is weak, closer to 1 is strong. And we go with a 0.5. If it's 0.5 or above, there's a relationship. But if it's below 0.5, there's not really a relationship. Any other questions? Okay, when you're trying the other problems, if you have any questions, let me know. Send me a text, an email. But if not, I will see you Thursday. The test should only take 50 minutes, but I will give you the whole time. And if you need more time, which you shouldn't, but if you did, oh, I don't have class after this. So then if you did need to stay on, you could stay on. Any questions?